After tearing the weighing paper, add about 0.125 grams of copper sulfate pentahydrate. Transfer the crystals to the 25 milliliter volumetric flask, then dissolve them in a small volume of water. Under the fume hood, I used a pipette to add drops of aqueous ammonia to the solution until the solution was clear and dark blue. This was copper amine. After filling water to the line and inverting the solution a couple of times, the stock solution is ready for serial dilutions. In a serial dilution, rather than taking solution from the stock each time, we can keep track of the concentration better by transferring a small volume from the stock to make the first dilution, then using a small volume from the first dilution to make the second dilution, and so on. Use a pipette to draw up a volume of stock solution, then transfer it to another flask and fill water to the line. Use the difference between the initial and final milliliters you use to calculate the volume. After this step, you should find that your dilutions are clear and have difference in lightness of color. Lastly, we took 5 milliliters of an unknown copper solution and added aqueous ammonia so that we could determine the relationship between absorbance and concentration. We then used pipettes to transfer the dilutions into cuvettes to prepare for the spectrophotometer. Setting the wavelength to 560 nanometers for this solution, we must use a blank, water, as our control and press 0. Each side of the cuvette should be cleaned before placing into the spectrophotometer to make sure that the absorbance reading is not skewed. We should repeat this process with each dilution, making sure to measure the absorbance with the read button each time. After graphing, we see that as concentration increases, absorbance increases.